Okay, we're on page 131 of the note spiral, and we're continuing the hypothesis test. And I would highly recommend that you have it open so that you can see the recipe of success as you work through this, because once again, it provides you the step-by-step process that you need to follow in order to be successful. So, a credit card company wondered whether giving frequent flyer miles for every purchase would increase card usage, which has a current mean of 2,500. So it sounds like the status quo is 2,500. They gave free miles to a simple random sample of 37 credit card customers. So we know N is 37 and found that the sample mean to be 2,542. So X bar is 2,542 with a standard deviation of 109. So the standard deviation of the sample is 109. Because it's a standard deviation of the sample, then we know that we're working with a t statistic. Also, I should probably note that my degrees of freedom is 36, or n minus 1. So what is the status quo? What is life as we currently know it? And currently, we have a current mean of $2,500. If you want to use a dollar sign instead of writing dollars, that's great. Make sure, once again, that this is in Greek letters, so we're talking about mu. Do not be using X bar, because if you use X bar here, you will lose 25% of your score. Alternative, mu is, and I know, and by the way, I'm going to talk about always real quickly. Mu and mu, $2,500 and $2,500. So that part's not changing. This will always be an equal. The only thing is going to change is whether we're dealing with a less than, greater than, or not equal. All right? So less than, greater than, or not equal to, they're looking for increased, and they also use it somewhere else, would increase. So I'm going to say that this is going to be a greater than. All right? So at this point, we have our null alternative written. So the next thing we need to do is define our population parameter mu. So let, and by the way, that's supposed to be the Greek letter mu. It's not supposed to be an M. I just don't make good mu's. Let mu equal the true population mean credit card dollar amount. You might be able to shorten that up depending on your phrase, but please make sure you're always using the true population. And since we're dealing with the mean, you need to make sure you have mean. The true population mean credit card dollar amount, I think, is probably about as short as you can get it. The next thing we need to state is our conditions. The first condition, random sample. And they told us that they had a random sample. It said simple random sample of 37. So that is a given. So I don't have to do anything with that. All right. The next thing, we need to check the 10% condition. Well, we surveyed 37 people. So 37 divided by 0.10 equals 370. And I'm going to say, you know what? Reasonable to assume that there are at least 370 card users. So our sample is less than 10% of the population. And once again, we're doing that because technically we're drawing without replacement. And so we're checking to see if things are independent enough. And as long as it's less than 10%, we're good to go. All right, as long as the sample is less than 10%, we're good to go. And I'm going to say there's probably a lot more than 370 customers. The next thing is normality. And we have a couple ways of checking it. We can check to see if they told us it was normal. They didn't. We can check the data and graph it. Not a whole lot of fun, but you can do it to see if it's reasonably symmetric with no outliers. The next thing you can do is you can do by normal by central limit theorem. Unfortunately, in this case, that does apply because our sample size 37, which is greater than 30. Than 30. The distribution of means is normal by central limit theorem. All right. So let's go ahead. Now that we've done that, we need to write our equation. All right. And our equation for this is T equals X bar plus T, T equals X bar minus mu S divided by the square root of N. I'm going to draw a really quick picture of this. The claimed mean, or the status quo mean, was 2,500. We got a sample of 2,542. This is our X bar. And we want to know the probability that we'd get something as extreme or more extreme. When I say as extreme or more extreme, it means I need to be moving away from the population mean. So I'm shading up to positive infinity, and that's also consistent with our greater than statement. So that's consistent with our greater than statement, but it's also saying, hey, more extreme is moving away from the mean. All right, we've already labeled all of our input data, and so we're going to go ahead and run this test, or we're going to go ahead and plug in, and we want the probability that X bar is greater than 2,542, which equals a probability that T is greater than 2,542 minus 2,500, because that's the original claim, divided by our standard deviation of the sample was 109, and we had a sample of size 37. All right, I'm going to take a pause for just a moment. So if I take that same information, I say, okay, sample size 37, degrees of freedom is 36, alpha is 0.01, so our level of significance is 0.01. We get a critical value of 2.4344. And the way I did that, second vars, inverse T. Now, remember the calculator works from left to right, so I needed to go parenthesis 1 minus 0.01, or in other words, just 0.99, this area right here. Degrees of freedom was 36. And I get a critical value of 2.4344. So if when I run this, my test statistic is greater than 2.4344, I reject. If my p-value is less than 0.01, I reject. And those things should happen simultaneously. They should occur at the same time. So let's go ahead and run this and see and make those comparisons. So stat test, and we're looking at a t-test. And now we have a mean of 2542. Excuse me, that's incorrect. Population mean is 2,500. X bar is 2542. Standard deviation of the sample is 109. Sample size was 37. Now we have a greater than symbol and we're shading up, so we know we need the greater than. So let's make sure we highlight the correct one. And we put calculate. And we ended up getting the probability that t is greater than 2.3438 equals 0.01236. So there's my test statistic. This is my test statistic. And I just read that straight off the calculator. All right. My test statistic of 2.3438, my p-value of 0.01236. So let's go back to our little drawing off to the side. Well, 2.34 is back over here. So this is where 2.34 is. So because it's not greater, it's not more extreme, based on our test statistic, we'd fail to reject because our test statistic is not as extreme as 2.434. Or my p-value of 0.012 is greater than 0.01. So once again, we failed to reject. So for these tests, we're going to use p-values. College Board seems to like them, and quite frankly, I think they're easier. So alpha is 0.01, p-value is 0.01236, or 0.0123. So let's make this the same size. 1, 2, 3, 4 decimal places. 123 is bigger than 100. So that's a greater than symbol. And if it's greater, if our p-value is greater, we fail to reject. All right, so now we're going to go back and we have to write our conclusion, and we're going to use our conclusion writing that same template, and everything we've used up above up here is going to help us with that. So first off, our p-value, what was it? Our p-value is 0.0123. What was our decision? We fail to reject. What do we fail to reject? Fail to reject the null. There is not. All right. If you reject, there is, but if you fail to reject, there is not enough, sufficient evidence at alpha equal 0.01 to suggest that. Now we restate our definition, and our definition was a true population mean credit card dollar amount. That the true population mean credit card amount is, restate the alternative in words. We had a greater than symbol, so is greater than $2,500. So what we basically said is we made these changes with advertising, or what are free miles, I guess they had the thing, and we wanted to know if it increased it. And what we found out was, well, yeah, 2,542 is above 2,500, but there's not enough evidence to say that there was a change. It does not look like it increased. So based on this, it could have happened by random chance alone, 0.0123 times. So essentially, the frequent flyer miles didn't work based on this. All right, based on this, we'd say the frequent flyer miles did not work. Now you go, well, what if I would have had a p-value of 0.05? If you had your alpha had been 0.05. Alpha been 0.05, we would have rejected, but they wanted a more stringent mode. All right, they wanted something a little more critical, and so they're going to say, hey, it didn't work. All right, so that concludes that video.